There are many devices manufactured by humans that have memory. Computers, cell phones, and other things. But examples of devices that do not have memory are coins, dice, decks of cards, and urns of marbles. So this means if we do experiments with these types of devices, after we observe the outcome of one experiment, we shouldn't feel any differently about the outcome of the next experiment, because it's exactly the same as the first time. Now with a deck of cards or an urn of marbles, I'm assuming that we're experimenting with replacement. Whenever we choose a card, we put it back so we can do the same experiment again. Whenever we choose a marble, we put it back so we can do the same experiment again. So this means assuming that we have inspected our objects for symmetry, if xi is the outcome of the ith trial, then the probability of xi given xi minus 1 is just the probability of xi. Just like we had never done the experiment before. So for a coin, which we've inspected it for symmetry, probability of h is, well, the probability of, let's say that our nth trial is h, is 1/2. The probability that the nth trial is h, given that the n minus first trial is h, is also 1/2. The probability that the nth trial is h, given that the last two trials were h, equals 1/2. Because the coin has no memory. No matter how many times we flipped it, flipping it again is just like flipping it for the first time. Now when we observe coin tosses or rolls of dice or the other experiments, perhaps a real person might differ from our ideal person, which we base probability on. The real person has emotions which might interfere with probability computations. Our ideal, say perfectly intelligent, human who we base probability on doesn't let emotions interfere. So for example, after observing a few heads in a row, a real person might become more confident about seeing heads. because it looks like the coin often lands heads. But this is illogical if the coin has been inspected for symmetry. We should still feel the same. 1/2 heads, 1/2 tails, no matter how many times we see heads in a row. On the other hand, a real person, after observing a few heads in a row, might be more confident about seeing tails. Because after a couple of heads, if we feel like the coin lands on tails half the time, because it might be time for the coin to switch to tails. But again, this is illogical. Assuming we've inspected the coin for symmetry. Alright, now let's look at this problem from the coin's point of view. After landing heads a couple times in a row, how does the coin feel? Well, the coin doesn't feel anything. It doesn't have any feelings. It doesn't even have any memory. It doesn't remember that it landed heads a couple times in a row. Which brings us to our experiment. So Sophie and Wasti in our class both provided me with a list of results of 20 coin tosses. Except that one of them actually tossed a coin and one of them just faked it and gave me a sequence of 20 heads and tails. So if I look at their emails and get the list and put them up on the board, I wonder if we can compare them and decide which one was actually flipping a coin and which one was faking it. Alright, here are the results which I just put up. So Sophie gave me this sequence and Wasti gave me this sequence. I put the tails and heads in different colors to make it easier for us to spot the differences. Now normally I would distinguish between a fake sequence and a real sequence by looking at sequences of subsequences of heads in a row or tails in a row. And I would think that usually a human being would be too embarrassed to put too many tails or too many heads in a row. But we can see in both of these sequences that they both have 3 heads in a row and 3 tails in a row. So it makes it hard to distinguish. Wasti actually did twice 3 in a row. So I would say that that would be 1 point in favor of Wasti for being the real coin tosser. So no fear of 3 in a row. Normally I think a human being would be embarrassed to put 3 in a row too many times. So it looks like he has less fear of a 3 in a row than Sophie does. If we look at the human being knowing that the coin should land on heads half the time and tails half the time, I think would be more tempted to write heads, tails, heads, tails, heads, tails, alternating like that. So if we look at number of things that are larger than one in a row, 2 heads, 3 tails, 2 tails, 2 heads, 2 tails, 2 heads. So that's 1, 2, 3, 4, 5, 6 for Sophie. 1, 2, 3, 4, 5 for Wasti. So I think I'm going to give a point to Sophie for possibly being the real coin tosser for less fear. I'm going to say less fear of 2 or more in a row. And if we look at alternating tails, heads, which I feel like a human being would want to do, we've got tails, heads here. Got 5 alternating there. We have a 3 here. Tails, heads, tails, heads, tails, heads, tails, heads, tails. Ooh, that's a lot of heads, tails in a row. 1, 2, 3, 4, 5, 6, 7, 8. I think I'm going to put that under less fear of 2 or more in a row. So maybe for 2 reasons, I'm going to give Sophie a point there for possibly being the real coin tosser, for not having such a long string of heads, tails in a row. I have to say this is really close. It's not obvious to me who actually tossed a coin and who didn't. But I think I'm going to vote for Sophie based on this little bit of analysis. Alright, now I'm going to send email to them and to find out who actually tossed the coin and who faked it. And we'll see if I'm right. I'll put it up as a PDF file. The end.